What you're looking at right now is the CyberSponse platform itself. As an incident responder, you're going to spend most of your life either in the alerts for violations or incidents page. In the alerts page, what I'm going to do is I'm going to generate and execute a simulated alert where you have an asset that's specifically infected that you need to do something with access data in order to capture the memory. And so with that, I'm going to go down and I'm going to run a simulation of access data. Where is it? I just saw it. So when I run that, you're going to see it create a new alert at the top where there's a successful inbound connection. What this does is it creates an alert of an unknown on a specific port 31337, and that is specifically because you've got a connection coming in inbound to a specific asset. And if we look at it down here in the asset record, it's the CEO's laptop of the organization. Well, that's a pretty important connection that you see that's happening on your network that you might have to respond to. So all we have to do in the automation world, if we want to remediate or get a capture from access data, is I highlight that asset and I execute a full access memory job. And what you can see happening over here on the right-hand side is access data is actually running playbooks in the behind the scenes, and I'll show you those in a second, that actually captures and communicates with Access Data Enterprise to capture the memory of that actual laptop itself. Steve, following my demo, is going to be able to show you that. And so what you can see is the assets are correlated to the events, to the hunts, to the incidents, to the vulnerabilities around this specific alert that came in. That's where your ability is to interface with all those other products that we talked about. So it's curious, what does that playbook do and what did we do today? So when I run the View Executable Playbooks option inside the incident or alert record, I can see that I've added comments related to the asset, I've waited 10 minutes, I've been able to grab a second comment, and I was able to execute a specific asset. So I'm opening a page right now, which is the playbook engine. And that playbook engine is exactly what ran behind the scenes, and I'll walk you through this real quick. By creating that trigger, I ran into access data, and I created a case around access data. I then added a comment to the record. I found the related the asset, which is the CEO's laptop. I waited 10 seconds for it to get ready to communicate and build the connection between the two. I executed the volatile memory acquisition. I added a second comment to the record that the acquisition took place. I got the job status back from access data. Then I added the volatile data to the case that I retrieved from access data itself, and then I added a completion comment. So what you can see is all the red icons is where we actually automated and integrated with access data in order to automate the forensic aspect of it. The value of that is you no longer have to jump between products anymore. You can execute and control, almost like a remote control console, all the executables that need to take place in order for you to capture that data within the incident response record. And so those playbooks, like I said, and if you want to do more investigations with that, you could add more approvals, you could add more steps, more connectors to more products. You could take that memory capture, do further evidence or collection data or scanning with it as well, or extract specific indicators of compromise from it. You can do that all through using the platform itself. And with that, I'm going to let Steve take over from his part.
What Joe just showed us was the automated playbook and the data that was grabbed using Access Data Enterprise. What I'm going to show you is the data in the Access Data GUI so we can actually view it. He grabbed in that playbook, there was an incoming connection on port 31337, and so we're going to go out and go ahead and take a look at the sockets that we grabbed, and this is going to be the connections. And we can see here is the CEO's laptop, and I can filter out established connections, and right away I can see there's 31337, that there's an active connection. His machine was .43, and there's an active connection from 10.1. So we know that it's looking at Notepad. We can see the process ID and the machine and the time and date that it happened. So now that I know that that's there, I can go up into the processes and look at it and see that the actual processes that we're running, and we'll find somewhere in here is my Notepad. We can see that Notepad is actually running on this box. And we can see the command line of it. And if I look at the command line of it, it looks like a netcat listener. So it's -L, so sitting on port 31337, it's executing a command line. So The command is right underneath it, so we can see the parent ID is the same process ID of the notepad, so we definitely know that we're tracing the parentage of this command prompt, and Notepad did spawn that. So what we also can do is take a look at all the network drivers and the users on the machine, and this is all the information that it grabbed, so we can look at open files and the DLLs. On top of that, what I've done is I had a scan of the CEO's laptop, so I can do a comparison from scan A to scan B. So this is a scan prior to anything happening, so I can left click and then right click, and I can get a quick delta of new processes that showed up from scan A to scan B. So we can see right here, here's my notepad that showed up, and we can see the same command line right there, and there's the command.exe. Looks like it's running out of the downloads directory from my user path, user Steve downloads command.exe, and there's the notepad that's running as well. I also can get new connections on here too. So if I can compare the two scans, same type of thing, anything in red shows up that's new. There's my 31337 running by notepad, and we definitely know we got an issue. So from here, since I'm in the GUI, I've already done this in the interest of time. I've gone and loaded a preview of the machine. So from here, I'm looking at all of the files on the machine. I can scroll down through them. There's 120-some thousand files on the box. I can scroll down through them. I can do a timeline. I can do all kinds of different stuff with these files. I can get all the properties. I can just click on one of them, and it'll give me the properties of the file. And I could offload the file. I could kill it if I needed to. It was the process. And on top of that, we know we have some executables on here that are bad. So what we can do is do a remote search on the box. We know we have a notepad running, and I can create an XML template to look for these files via hash. Since I have the processes, I know what the hash is, and if I open this up, you'll see in here, here's the hash value of the XML. I can show you how we created this, and it's a executable file. So if I just click search on that, it would go through on that remote box or any of the machines I have listed up here and search for that. Once it finds it, we'll come back and it'll show us the machines, the different files that we found. So not only do we find my notepad here down at the very bottom on that box, okay, we can see that's running out of my user directory under my user downloads directory. We can see there's a netcat listener running under the administrator's download directory, or there's a netcat on here. The key is that there's a bunch of files, and even here in the recycling bin, we found a couple of files that were deleted that the hash value actually matches up on that. So then we could go back over to our processes under the volatile information, and I could kill one of these processes. So if I take a look at the process, I could run a, right click on the process, and I could kill it, or I could wipe it, and I could add it to hash values if I wanted to. On top of that, while we're in here, I ran a module called System Information, which is going to glean a ton of information for our stuff, for our infected node. It's going to pull all the installed apps. It's going to grab all the prefetch files. So I can come here and take a look, the prefetches, where all the different things are. I can get my user assist files, downloads, URLs, network connections, and the shares on that box. So we can see if anything else was opened up on it, jump lists, shortcuts on the machine. I can pull the users on the box. I can parse out my shell bags on the machine. Also can grab USB information, and that's all in one nice little GUI that we can export. Same thing with the volatile data. I can export any of this information that I needed to. So also, while we're doing a preview of it, we can do a lot of things like, I can go and do searching. I can look for prefetch files, right? I can filter in on the prefetch files. I can find my command line that was executed and look at it in its natural format. And we grab this one here, and we can see here's the one that's coming out of Steve's on their downloads, and it was executed this afternoon, or when the alert happened. I can go down and grab through registry files. I can do a timeline on it, so I can see all the different machines, that anything that was accessed in the last couple of months or the last couple of days, last couple of hours, just by simply creating and writing filters. So to make a long story short, Joe's system, CyberSponse, got an alert, created an action through the playbook, went and used AccessData through the APIs, grabbed all the process information and the service information and all the volatile data. We're able to see that we definitely do have an incident, and we're able to investigate it and remediate it.
And that time to respond is where you're going to get a lot of value saving, right? As it's doing a memory capture, which takes a few minutes, you're saving time by executing it remotely before you have to go back, before you go into AccessData Enterprise in order to look at the data itself. So you're getting ahead of the curve, and so to speak. You're able to move streamline your process, especially when you start to automate things. You know how you saw I manually executed it? You can start automating when those executions take place so that you don't even have to have human intervention. You literally could say every time that there's a known compromise on an endpoint, automatically grab the memory or drive image of that device before you even open the alert. So that's kind of a proactive response that you can do that you can't currently do. You couldn't do at any other product combination yet today.
Yeah, and you can pass the API's variables from a CyberSponse system. So if you had a specific file name or something like that, you could go and grab it. You could use the APIs to grab the individual file. You could do a full disk dump, as Joe said, a memory dump, including a swap file, volatile data. A lot of the stuff that we can do manually in the GUI, we've automated to be able to make those response times a lot faster and almost instant.